Hello and welcome to another Ginger Mathematician video. So today I'm going to go through my predicted paper for paper 4. So this is the 2 hour and 30 minutes paper, and this is suitable for February 2024 and May 2024 as well. Again, the total mark for this paper is out of 130, so slightly bigger than the paper 2. And again, if you need any extra guidance, again, you can always use my all of IGCSE Maths playlist. Again, I'll link that in the description as well. And again, all the standard instructions are right in front of you here as well. Right, let's get started. So we've got question 1 here. So we need to calculate the volume. We'll zoom in slightly, of a solid cylinder with radius 4 centimeters and height 10 centimeters. So we've got some volume 3D shapes to start us off. Now notice sometimes they actually give us the formula directly, so for a sphere, but for a cylinder they would expect you to know this off by heart. Now the volume of a cylinder, just to remind you, is equal to the face of it, so pi r squared, the area of a circle, and then multiplied by h. So if we want to work this out here, we've got a radius of 4 and we've got a height of 10. So wherever I see a r, I'm going to put a 4. Wherever I see an h, I'm going to put a 10. So I'm just substituting r for 4 here and h for 10. And now I'm going to go to my calculator and work it out. Okay, so always make sure you've got your calculator handy for both paper 2 and paper 4. So now we're going to just pop this in. To get the pi button here, generally it's shift and the button down here, so pi. Then we're going to do 4 squared and then multiply by 10. Notice it often gives it to you in terms of pi, but if you press the SD button, that will convert it into a decimal. So let's double check we've got everything in there. Pi times 4 squared times 10. Again, always make sure you've got the right numbers in. That gives us 502.6548. 502.6548. ... Generally speaking, you'll be expected to round to 2 decimal places, so rounding at this point. So we get 502.65 cubic centimeters. Now on to our next part of the question. So we have a solid hemisphere, that's really important, with a radius of 4 centimeters. Now the volume is given for a sphere, however we have a hemisphere. Remember, that means we've got half of a sphere. So our usual formula would be 4/3 pi r cubed. Because we have half of that, we want to use 2/3 pi r cubed. Now our r here is just like the previous question, it's equal to 4. So we type in 2/3 multiplied by pi multiplied by 4 cubed. At this stage, this is just a calculator exercise. Again, we've got a fraction button here, so we can type in the 2/3 directly. Times pi, remember shift and down here, times 4 cubed. Again, you can use a few different buttons here. I'm just going to use this button to give me the 4 cubed. That gives us then something in terms of pi, but we can press SD and we work out 134.0412. 134.0412 ... And if we then round that, of course, to 2 decimal places, we get 134.04 cubic centimeters. Notice both questions are volume, so therefore we need cubic centimeters as our unit. Now on to part B, which is a nice follow through. The cylinder and the hemisphere in that part A are now joined together. Notice the same values here to form the solid in the diagram. And notice the solid is made of steel, and 1 cubic centimeter of steel has this particular mass, and we want to find out the total mass. Now notice they've given us a hint here. We need to use part A in order to work out the total mass. So the total mass is going to be the 2 answers we've already worked out. So these 2 things added together. So I'll just write this down for the examiner so they're clear exactly what I'm looking to do. ... plus 134.04 ... So we go back to our calculator. Notice we can actually use our previous answer, go to shift and answer, and then we add in the other part. Again, I'm trying to use as many decimal places as possible so I get the most accurate answer, so we avoid those rounding errors. we add those together, we get 636.696. So let's just write that in. So 636.696 ... This is in cubic centimeters, and the steel has a mass of 785 grams. So we need to then take our total volume. So our total volume, and we need to multiply that by 785. So we can work out in grams, that is, exactly how much the mass is. So we take our previous answer, again, using the answer button is really important. Stop any rounding errors. We're going to times that by 785. That gives us some big number. So 499,806.4473. 4473. However, this is in grams. Notice the unit here, being sneaky, is in kilograms. So we need to convert from grams to kilograms. How do we do that? So we take our answer and we divide by 1,000. Remember, there are 1,000 grams in a kilogram. And again, we can use the answer button. That saves us a lot of time here. So we go Shift Answer, divide by 1,000, giving us our final answer of 499.806. ... Again, we always round to 2 decimal places, so that's going to be 499.81 kilograms. Notice being really careful with no rounding errors and making sure we get the precise answer for the 3 marks. Now on to a related question. So 2,000 cubic centimeters of iron are melted down, and some of it is used to make 40 spheres with radius 2 centimeters. Calculate the percentage of iron that is left over. Again, we've got this key formula that we need to be aware of. So the first thing that we need to do is work out what cubic centimeters 40 spheres of radius 2 centimeters would be. So if you work out the total spheres, let's put it that way, that will be equal to 40 times each of these spheres. Now, a sphere is going to be 4/3. Notice it's a sphere, not a hemisphere, times pi times 2 cubed. So we need to work out that volume first. Again, back to the calculator. Very heavily calculator question, this. So we have 40 times 4/3. So let's pop in the fraction first. Times pi times 2 cubed. Again, it gives us something in terms of pi, but again, we can use the SD button. So you get 1,340.412 ... and that's going to be in cubic centimeters. And we need to work out what's left over here. So the way that we work out this percentage is we subtract one from the other. So we do 2,000 minus the answer from before. Okay, divided by the total amount of iron, which is 2,000, and then times by 100. Again, lots to put in our calculator, but just need to be very careful how we do this. So let's have a fraction here. We have 2,000 minus our answer from before. And using the answer button, really important, divided by 2,000, that's our total amount of iron, and we want it as a percentage, not a fraction, so we times by 100. That gives us then 32.979 ... percent. Again, we always round to 2 decimal places, so we get 32.98% of iron left over. Okay, the iron left over itself is then made into a cube. Okay, that's interesting. So let's draw a cube out here. So the key thing about a cube is that all lengths are the same. So this is x, this would be x, and this would be x. So the general volume of a cube is just x times x times x, which is x cubed. And what's left over is made into this cube. So x cubed is equal to the 2,000 minus 1340.412. So let's just work out what that is first of all. So probably the easiest way of doing this is just take this away from the spheres that we worked out earlier. So a little bit extra work to do. You have 2.5 hours for this exam, so take your time. Absolutely fine to just repeat some calculations. That's not a problem. And let's make sure this looks like a sensible number. Should be around, 500 and something. 600 and something. So 659.587. So 587 ... We want to work out one length of this, so we want to work out the x essentially. Again, what's the opposite of cubing something? That's the cube root, so we need the cube root on both sides. This cancels, giving us x, and now we want to find the cube root of this 659.587. And if we just find the cube root of that, then we can use this button here, and then we want the answer from before. That then gives us 8.7047. And again, we always do this to 2 decimal places, so it's going to be 8.70 centimeters for the 1 mark. Seems like quite a lot of work actually for a 1 mark here, but that's absolutely fine. If you had this in your calculator stored already, just find the cube root and boom, you've got your answer. Now on to the more AA star element of this question. So a solid cone has radius 3r centimeters and slant height 9r centimeters. So as I go through the question, what I generally do is just draw a sketch. So we have a cone. Let's just pop it over here. Again, my terrible drawings, but hopefully seems clear enough. And we have a radius. So let's get a different color pen here. So we have a radius of 3r centimeters and the slant height, that's important, of 9r centimeters. Okay, then we have a cylinder. So we have a cylinder. Let's draw this out. My great drawing. Came bottom in year 8 art a long time ago. That's a story for another day. Alright, so let's pop this in. So we've got a radius of x and the height is equal to 7x centimeters. And the total surface area, surface area, is equal to the total surface area of the cylinder. Given that r is equal to kx, find the value of k. And we're given some useful formula here. So we're given the curved surface area of the cone is equal to pi rl. Okay, so let's start with the cone first of all. So the surface area of the cone, so I'm going to call this TSA, total surface area, is equal to the pi rl that we talked about before, about the formula, that the curved surface area, so this bit going around here, but we also have to add in the base as well, and the base is just equal to pi r squared. Okay, so let's pop things in. So we have pi lots of 3r times 9r, okay, plus pi r squared, so pi times 3r all squared. Just popping these things in very carefully. That gives us then, we have 9 times 3 is 27, we have a pi and we have an r squared. And here 3r all squared, be really careful with this, 3r times 3r, that's 9r squared. So we get 9 pi r squared. And we have 27 pi r squared and 9 pi r squared. That's going to give us 36 pi r squared. So that's our total surface area in terms of r. Now let's take our cylinder over here. So the total surface area of a cylinder, you may have learned a formula off by heart for this. Generally, I tend to write it as 2 pi r h. So that's the curved surface area, so this one here, plus 2 pi r squared. So that's the top part of the circle and then the bottom circle as well. So if we pop this in, seems my favourite word, pop this in. So the radius equal to x, so we get 2 pi x, and the height is 7x. And then we have 2 pi, not r anymore, but we have an x squared. So if we collect this up, what do we get? So we have 7 times 2 is 14, 14 pi x squared, plus 2 pi x squared. How many pi x squareds? That's 16 pi x squared. So that's our total surface area now for the cylinder, and we're told that the total surface areas of the cone and the cylinder are equal. Therefore, we can say that this must equal this, and we want r on the left hand side. So we have 36 pi r squared is equal to 16 pi x squared. Okay, well, we can cancel out a pi from both sides. That's useful. We can take a common factor out of 4, so we can divide both sides by 4 here. 36 divided by 4 is 9, so we get 9r squared is equal to 4x squared. 16 divided by 4 is equal to 4. Then we can bring over the 9, so we divide by 9 on both sides. That cancels, giving us r squared is equal to 4 over 9x squared. And now we want to get the r on its own. So the opposite of squaring is square rooting. So we square root both sides. These cancel, giving us just r. The square root of 4 is 2. The square root of 9 is 3. That's a really good sign. We're getting whole numbers here. Don't have to, but good sign. And the square root of x squared is just x. So after all that very complex calculation, we actually have a very nice value for k here. It's just equal to 2/3. Okay, if you got that question correct, really well done, because that is a typical AA star question for volume and areas of 3D and 2D shapes. Right, on to question 2 here. Now, if you're looking for some up-to-date revision day style material, I've just launched an IGCSE Maths exam workshop. If you're interested in that, then do click on the link in the description. And again, I'll go through for about an hour and a half, 5 critical topics you need to know for paper 2. Right, let's continue with question 2 here. First of all, we need to simplify fully. So some indices questions, which I do go through in that workshop as well. So here, remember, with small numbers with division, we are minusing the small numbers. So we have to be very careful here. 11 minus minus 3. 2 minuses make a plus, so 11 plus 3. And that gives us f to the power of 14. Next question here, again, we've got it as a fraction. We can simplify first of all. So how many 5s go into 5? 1. How many 5s go into 15? 3. So we get 3n cubed over n squared. Again, if we're dividing here, this is the same as doing 3n cubed divided by n squared, similar to what we did in part 1. N to the power of 3 divided by n to the power of 2 is n to the power of 1, which we could just write as 3n. A fairly generous 2 marks there. On to part 3 here. So we've got some negative indices. As soon as I see a negative index, again, we want to flip our fraction. So we get 25 over 49 x to the power of 4, y to the power of 6. And then we make it positive. That's how we deal with the minus. And now remember, the power of a half means the square root. So we want the square root of the top, and we want the square root of the bottom as well. So careful with our square rooting here. The square root of 25 is equal to 5. The square root of 49 is 7. Now this is where we have to be careful. If you do the square root of x to the power of 4, that's the same as x to the power of 4 to the power of a half. When we're working with brackets, we multiply the indices. So a half of 4 is equal to 2. So we get an x squared here. If we do the same process here, we just get y to the power of 3. So we have 5 over 7x squared, y to the power of 3. Again, you can pick up lots of marks by being really confident with your index skills. On to some quick bit of sequences here. So a sequence has the nth term a half n squared. Write out the first 3 terms of the sequence. So we want U1, U2, not the band, and U3. So first of all, wherever we see an n, we put a 1, so we do a half of 1 squared. Well, 1 times 1 is just 1, and a half times 1 is just a half. So that's our first term. This one here, we want to do a half of 2 squared. 2 times 2 is equal to 4, and a half of 4 is equal to 2. And the last one, we have a half 3 squared. So we have a half times 9, remember 3 times 3, and that gives us just 9 over 2. We could write these as decimals, so if you wrote this as 0.5 and 4.5, that's absolutely fine as well. Now on to the nth term for each of these sequences. Again, whenever I see an nth term question, I'm always looking for the difference. That's the first thing I'm looking for here. Notice we keep subtracting 3 each time to get the next term. So our nth term will be minus 3n because we have an nth term. And what do we do to minus 3 to get to 13? We add on 16. So that will be our answer here. How would I check this in the exam? Well, if I put n is equal to 1 here, 16 minus 3 is equal to 13. Okay, I'm getting the correct first term here. Here we approach this in a very similar way. So we look at the differences. So we have a plus 14 here. At this point, you can start using your calculator. If you're like, oh, 56 minus 18. It's a good exam tip. I mean, why do these mental methods when we just have a calculator? You can double check. So we have a plus 14, a plus 38, and then we've got these two. So we just find the difference. Again, under stress, just using your calculator effectively is really worth it. So we have plus 74. And then the last one, so we have 252 minus 130. We get 122. So we get these differences. Then we want the difference of the difference. So here we get 14. Difference between 38 and 14. That's going to be 22. The difference here, again, if you're not sure about this, you can always use your calculator. You get 26. And here, again, we're always double checking these things. Okay, that's why we double check. So we get 36. And 122 minus 74. Get 48. Okay, and then the difference of that is going to be 14. Okay, this needs to be 4. Again, this is why you have to be careful with these. Again, just use your calculator. The difference between this is 24. So we get plus 12 and plus 12. Finally, we get a difference. So not a second difference, but a third difference, which rarely comes up, but it's useful to be aware of. Now, if you get a third difference, you know it's got something to do with n cubed in. So that's in my mind at this point. And with third differences, we divide by 6. That's important. That gives us 2. So actually, we should be thinking not just about n cubed, but 2n cubed. So we need to think about the sequence of 2n cubed. So I'm going to write my sequence that I already have. So let's just pop that in. It's quite a tricky question, quite early on in the exam. But we want to work out 2n cubed, 2 coming from here, n cubed from the third difference. So again, we want the cube numbers and then times by 2. So 1 cubed is 1, 1 times 2 is 2, 2 cubed is 8, 8 times 2 is 16, 3 cubed is 27, 54. Okay, this is looking quite nice. 4 cubed, that's 128. 5 cubed, that gives us 250. Notice if we subtract the two sequences from each other, 4 minus 2 is 2, 18 minus 16 is 2, 56 minus 54 is 2. We keep getting 2 each time. So our nth term is going to be 2n cubed. So this part here, and then what we have to add to get to this sequence. So we get plus 2 there. That's quite a tricky one, and again, it's something you should definitely work on. I find this gets under-taught, like most teachers are aware of linear sequences and quadratics, but cubics are also on the course as well. So, question D here, we want to solve this equation. Again, standard procedure here, we have a divide by 5, kind of annoying, so we want to multiply by 5 on both sides. This cancels, giving us 3x minus 3. 120 times 5, that's 600. Then we just go through our standard process. We have a minus 3. The opposite of that is adding 3 on both sides. This cancels, giving us 3x. Get 603. Again, you could use your calculator at this point. You need to divide by 3 on both sides. This cancels, giving us x. If you divide this by 3 mentally or otherwise, we get to 201, which will be our answer for 3 marks. Kind of strange that this question here is actually the same amount of marks as that cubic sequence we just did. Okay, and now we need to use the quadratic formula. Thanks for telling us in this question to solve 5x squared minus 2x minus 11 is 0. Again, giving the answer to 2 decimal places. Now, a quadratic formula is equal to minus b plus minus the square root of b squared minus 4ac all over 2a, where this here is our a, this here is our b, and this here is our c. So let's substitute it in correctly. So we have x equals minus b, so minus minus 2, that's positive 2, plus minus square root of minus 2 squared minus 4 times 5 times minus 11 all over 2a. Our a is 5, so 2 lots of a is 10. Let's just keep going through nice and smoothly. So we have minus 2 squared, that's equal to 4. This term is always positive, good to remember here. And then we have 5 times 4 times minus 11. So that gives us 5 times 4 times minus 11 minus 220. So minus 220 all over 10. Be careful, this always has to be positive. They won't give you one. We get a negative square root. So if you're getting a negative square root, bad things are happening. This gives us 224 over 10. And now we want to work out the two answers. So x1 will be 2 plus 224 rooted over 10. x2 will be 2 minus root 224 divided by 10. At this point, this is a case of just putting it into our calculator and not making any silly mistakes. So we have the square root of 224 divided by 10. In SD to give us a decimal, 1.696, so that's going to be 1.70 when rounded. And we do the other one here. So 2 minus the square root of 224 divided by 10. And again, SD button is our friend, and here we get minus 1.2966, that's minus 1.30. Again, make sure your rounding is on point here to 2 decimal places. Okay, on to question 3 here. So the height of each 100 plants is recorded, and table shows information about the height of them, and we need to complete the histogram. Again, it's a key topic, histogram, cumulative frequency graphs. Again, you're going to see some stats in this paper for certain. Notice a little hint here is it gives you frequency density, so you use that as a trigger for the right thing. Notice the scale is quite different to the frequency that we have here. The easiest way of doing this is creating yourself an extra row, and we need to work out the frequency density. The way that we do that, and remember this formula for FD, frequency density equals the frequency divided by class width. To keep that in mind here. So how do we do that? Well, we've got an 8 here. The width here between 10 and 15 is 5. So we do 8 divided by 5. So for this term here, 8 divided by 5. Again, we use our calculator to get the answer of 1.6. Now notice I will double check this. So I'll look at our diagram and notice this does go up in 0.05s. So yeah, it is at 1.6. So we've got the answer right here. Here, the width here is equal to 10. Again, the widths do change here, so be careful. This is 15, this is 20, and this is 10. So 18 divided by 10, that's 1.8. Does that go to 1.8? Yes, it does. And now we continue in the same process. So we have 28 divided by 15. That gives us 1.87. Again, I'm going to double check all these things. Again, we've got 33 divided by 20. That gives us 1.65. And then last one, divided by 10, is 1.3. So if we want to draw this histogram here, we want 1.87. So 85, 1.9, so it's going to be somewhere in between here. And we need to go as far as 40. Going to make your eyes dizzy on the screen, much easier in real life. And making sure I've got exactly the right one here. Yep, so we go up to here, come across, and then using a ruler, which I'm not using here, but you should definitely use in the exam, that comes down to 40. Then we've got 1.65. Okay, so 1.65, so we've got, this was 1.6, so it's just one up from here. And we're going across as far as 60. Try not to get dizzy when looking at this, so we'll go across like this. Yep, and down here, just double checking, making sure you use a ruler. Perfect. And then the last one is going to 70, 1.3. So that's 1.1, 1.2, 1.3, and just goes all the way across to the end, which helps us a little bit with our drawing. So we get the 3 marks. Just be very careful. And the key exam tip here is to use these values to check you're doing the right process and not the other way around. After this, we need to work out an estimate for the mean height. So the way that we do this is we work out frequency times midpoint. So I'm going to create a new column here to represent what we have and pop this in. So let's have a look. We've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're taking the middle. So don't take what we just did here. You want the middle of this. So you've got 12.5, 20, 32.5, 50, and 65. And we just do 12.5 times 8. So again, that's just going to be 100. But you can always check on your calculator. So we get 100 here. Next one, 20 times 18, that's 360. Some of these are nice, easy to work out. That next one isn't so easy. 32.5 times 28, 910. And last one, 50 times 33. Again, use that calculator effectively. 1,650. And then 13 times 65. That's 845. So we need to add up those values here. Notice I'm just separating these out into separate calculations. 150 plus 845. That gives us 3,865. And to work out the mean here, or the estimate of the mean, we do 3,865 divided by the total number of plants, which is equal to 100. That keeps our life easy. And if we divide that by 100, we get 38.65 centimeters as our estimate. Now, does that make sense? I'd always go back and double check. 38, yeah, I mean, it's generally clustered around the middle, getting more towards the top end, so more towards the end of the 40s. So 38.65 makes logical sense. If you're getting something sort of ridiculous like 3.8625, that doesn't really fit the data that we actually have here. So 38.65, I'm happy with that particular answer. Okay, and on to question 4 here. So Clara here is playing a game with these 6 number cards. So we've got these 6 number cards in front of us, and she takes 2 cards at random. This is really important phrase, should probably be in bold, without replacements, so not replacing them, and adds the 2 numbers to give a score. And we need to find the probability that the score is equal to 8. So we could actually write a big diagram out here, but let's just think about this a bit more logically. How can we actually achieve 8 here with only 2 cards? Well, we can certainly do 3 plus 5. That's equal to 8. And of course, we need to consider the other way around as well. Is there any other way of actually getting 8 here? And these are the only 2 combinations available. So we need to work out the probability of 3 and 5. And then add that to the probability of 5 and 3. Well, the probability of getting a 3, that's going to be 1 out of 6. And then the probability of getting a 5 here, and we've taken 1 card out already, because there are only 5 cards left, would be 1 out of 5. Notice, whichever way round we do this, it doesn't actually make any difference at all, because there's 1 of each card here. And if we work out these 2 fractions, 1 out of 6 times 1 out of 5 is 1 out of 30. So we get 2 lots of 1 out of 30. That means then we get 2 out of 30. Remember, adding fractions, you add the tops together, and that simplifies down to 1 over 15. I do recommend you do keep your probabilities as fractions. Again, it'll just keep things a bit easier as we go through the question. Next question, I like this. It seems similar, but actually there's a nice little twist here. The score is a positive number that is above 0. Now notice here, with only 2 negative cards and 4 positive, that's a lot of different combinations to work out. So let's take a negative approach to this, which is we can do 1 minus, remember all probabilities add up to 1, the probability that the score is 0 or less. That's going to make it much easier to work out here. Now, let's think about what's the probability of score 0 or less. So which combinations will give us either 0 or less than 0? Well, certainly minus 2 and 2 and the other way round. That gives us 0. Minus 3 and 3 and the other way round also work. And of course, don't forget we can get minus 2, minus 3 and the other way round. And finally, we can also use minus 3 and positive 2 and the other way round. So in total here, we actually have 8 different combinations that would give us that particular answer. There's nothing else that will work here. For example, if we did 3 and minus 2, that still gives us positive 1. So notice here we have 8 different combinations. Each combination will just be 1 over 6 times 1 over 5, just like we saw before. So each of these combinations has a 1 in 30 chance of occurring. So we've got 8 of these, so the probability will be 8 over 30. Notice much fewer than working the other way round. So our answer here is going to be 1 minus 8 over 30. Now we can use a bit of fraction work here. 1 is the same as 30 over 30. And we minus 8 over 30, giving us 22 over 30. Or we can simplify this down to 11 over 15. So it's important with these kind of questions. I like this question. Thinking in a more positive way, adding combinations or subtracting combinations from it. Now our last question is now Regan, should be Clara, and now takes 3 cards at random from the 6 cards without replacement and adds 3 numbers to give a total. Find the probability that her total is equal to 5. So again, we need to think about combinations that give us 5 from 3 cards, and exactly 3 cards. Well, notice we've got these minus 2 and plus 2, minus 3 and plus 3. So the way we can achieve 5 is either minus 2, minus 3 and 5, or we can also achieve 5, minus 2 plus 2 and 5, or minus 3 plus 3 and 5. That's the only ways we can get those combinations. Now let's have a think. The probability of getting a minus 2, a plus 2 and a 5, Well, that's going to be 1 over 6 times 1 over 5. Remember, we're not replacing here, so times 1 over 4. If we multiply this together, we get 1 over 120. Again, that's going to be exactly the same for minus 3, plus 3, and 5. We still have 1 over 6, 1 over 5, 1 over 4, which is 1 over 120. So our answer here will just be those two combinations and all the different permutations added together. So we get this, giving us two lots of 120, which is the same as 1 over 60. I like this question because generally they give you a tree diagram or sample space diagram to work your way through. However, here, thinking about combinations, again, which is also a skill on the IGCSE course, is a more effective way to get to the correct answer. Right, on to our next question, which looks like a circle theorem question, but it could be something else here as well. So, ABC are points on the circle, DE, the line at the bottom, is a tangent to the circle at C. Show that angle ABC is equal to 70.2 degrees. Okay, so we're looking for this angle. That's kind of our question mark here. Okay, well, if we draw this out separately, so ignore the circle for the time being. If I just draw this out, we have 10 centimeters here, we have 7.7 centimeters here, 9.5 centimeters here, and we're looking for an angle. Let's label this up A, B, and C. Okay, that means then that we've got three sides and looking for an angle. We're going to be using the cosine rule. Again, being able to recognize that is very, very important. Now, generally you're given this formula here, minus 2ab cos C, but a rearrangement is very helpful here. So cos C, this is generally the way I'd recommend to do this, it's a squared plus b squared minus c squared over 2ab. So that's the formula we're going to use. However, we need to recognize which side is which. So in this particular situation, we're looking for this angle. This one opposite is going to be our small c, and the other two sides make up our small a and small b. So we pop this into our formula, so we get cosine of c equals 9.5 squared plus 7.7 squared minus 10 squared all over 2 times 9.5 times 7.7. And of course c is going to be the inverse cosine of what's above here. Remember, the opposite of cosine is inverse cosine on both sides. So let's go to the calculator and work this out. So make sure it's in degrees, otherwise bad things will happen here. So let's get our fraction ready. So we have, well, let's have 9.5 squared. And just be really careful as we pop this in. Plus 7.7 squared minus 10 squared 2 times 9.5 times 7.7. It's going to give some horrible decimal, that's right. Then we'll do inverse cosine of this answer, shift answer. And that gives us 70.207. which if we round this gives us the answer that we're looking for. I love these show that questions, they're great. Give you 4 marks on this is quite generous. But again, some students may have to rearrange the formula rather than knowing this formula off by heart, which for IGCSE, this will save you a lot of time to know that off by heart. So from that, we need to work out some variety of different angles. Let's pop in this angle first of all. So we're told this here now is equal to 70.2 degrees. And let's work our way through. So angle AOC, AOC. So this angle here. Okay, so we need to remember the rule that the angle at circumference is twice the angle at the center. So to work out this angle here, we just take our original answer, 70.2. Again, this is why they've done this. Even if you got this wrong, you can still use this. So we can times that by 2. Let's give us 140.4 degrees. So I'm just going to use the angle just in case I did get that wrong later on. So that'd be 140.4 19.4 degrees. Here's obtuse angle, that makes lots of sense. Then we've got angle ACO, so ACO. Okay, so here we have an isosceles triangle. Notice these are both radiuses or radii of the circle. So to work out these two angles here, we just do 180 minus the 140.4 dot dot dot. Let's quickly do that one here. So 180 minus 140.4, which gives us 39.6 degrees. And then because isosceles triangle, we divide that by 2. And that gives us 19.8. So we'll do that as 19.8 degrees for that angle. And then we've got angle ACD. ACD, this angle here. What do we get that as? 19.8. And now we need to remember the rule that a tangent and a radius meet at a right angle. So we need to do 90 minus the angle we just worked out. Notice they do this in order to help you through the question. So we take our previous answer, 90, minus 19.8 degrees. And that gives us 70.2 degrees. So let's pop that in. And 1 mark questions, it shouldn't be anything too complicated to get to the answer. Okay, and from there we need to calculate the radius of the circle. So we need to calculate OC here. Right, so here we've got, this is also 19.8 degrees. We've got this here at 10. So what's coming to mind here is the sine rule. Notice we've got an angle on the side, another angle, and we're looking for this side here, OC, which is a radius. We could also do OA as well. So if I draw this out as a separate triangle, probably makes it easier to visualize. So we have a triangle that looks like this. We've got this at 10 centimeters. We know the center angle is 140.4 degrees. We're looking for this side. Let's just call that A. And we know the side angle opposite is 19.8 degrees. So to use the sine rule, we do A divided by sine of the angle opposite, so 19.8 degrees, and that's equal to 10 over sine 140.4 degrees. Again, we want to make A the subject here. So what's the opposite of dividing by sine 19.8? No, I'm going to say times by sine 19.8. That gives us 10 sine 19.8 degrees divided by sine 140.4 degrees. So let's pop that into our calculator. Let's use the one on screen just so you know where the sine button is. So fraction button, 10 sine 19.8 divided by sine 140.4 gives us 5.314 dot dot dot, and that's rounds into 5.31 centimeters. Again, it seems a reasonable length as well if we look at the diagrams, not to scale of course it says here, but yeah, this to be 5 centimeters, yeah, that could certainly be fine. Now we need to calculate the area of triangle ABC as a percentage of the area of the circle. Okay, so we'll probably need to use this unrounded version a bit later on. So the area of the circle, that's just going to be pi r squared, so pi times this 5.314 dot 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 squared. So we'll work that out in a moment. And now we need to work out the area of triangle ABC. Now we've got lots of sides of ABC. ABC, yeah, just using this angle and then these two sides make a lot of sense here to work out the big triangle. So we're going to use half AB sine C here, which is a formula you need to know. That means we're going to do a half times Let's see which sides we're using here. 7.7 and 9.5 times the sine of the angle in between, which was the 70.2. Okay, and then we need to work those out. And to work out the percentage of the area of the circle, so the final calculation here will be area of circle minus the area of triangle divided by the area of the circle, because the circle is bigger than the triangle here, and then times by 100. Notice I haven't really rushed to my calculator. Again, I've set out my working nice and neatly and used the calculator in one fell swoop, in one action essentially. So if we pop this in, we get area of the circle, so that's shift pi times, now the answer to this 5.314 is our radius, so we can go answer squared minus the area of the triangle, so that's 0.5 times 7 times 9.5 times the sine of 70.2, close bracket. Then we want the area of the circle, so that's just, put this in brackets to be sure, pi times, again, the answer squared, close brackets. And we want a percentage, so we times this whole thing by 100 at the end, and we get 61.211. So this works out the percentage that's not the triangle. So to work out the percentage that is the triangle, then we just do 100% minus our answer, and that will give us percentage of the triangle, so just 100 minus answer, 38.8%. That's to 1 dp. Probably should do this to 2 dp. 38.79. 38.79% for the 4 marks. Okay, on to some vectors here. So we've got P and Q given, and we need to find 3Q. So 3Q is going to be 3 lots of minus 2, 5. So we times both numbers by 3. That gives us minus 6. 5 times 3 is 15. And then we've got something like a mixture of, so we've got 2 lots of 3, 4, minus Q, so minus 2, 5. So we just timed each of these numbers by 2. That gives us 6, 8, minus 2, 5. Now be careful here. 6 minus minus 2, that's equal to positive 8. 8 minus 5 is 3. So be always very careful with your negative numbers here. And then we have these lines here. This is basically looking for the magnitude of the vector. And this is a formula you can just learn off by heart. So remember, our p vector is equal to 3, 4. So the magnitude of the vector will be the square root of 3 squared plus 4 squared. So it's just Pythagoras essentially. This gives us then square root of 9 plus 16, which is 25, giving our final answer of 5. Again, this is a 1 mark question, 1 mark, and then 2 marks for knowing the magnitude of a vector. Now this question is quite a nice one here. So B is the point 3, 4. Now I always draw a diagram just to get an idea of what's going on here. So we've got 3 and minus 4, so something down here. Excuse me. And AB, so the vector AB is equal to 2 minus 7, and we need to work out the coordinates of A. So going from A to B. What would be more useful for us is knowing the vector B to A. And all we need to do there is just switch the signs. So we need to do minus 2 and plus 7. Now remember, the top number tells us to go 2 to the left. The bottom number tells us to go 7 upwards. So all we need to do from here is go 2 to the left and then 7 upwards to get our new coordinate. Well, 3 minus 2, that's going to be equal to 1. And then minus 4 plus 7, that's equal to 3. So our new coordinate for A is going to be at 1, 3. Again, you could always check this by actually just doing the vector A to B. 1 plus 2 is 3. 3 minus 7 gives you minus 4. And on to a very typical vector algebra style question here. So in this triangle, we've got M as the midpoint, and K divides the line GH in the ratio 7 to 3. So what that means is here, this is 7/10 of the line, and this is 3/10 of the line. The vector OG, so this entire vector here, is equal to G. The vector OH going all the way across is equal to H. And we need to find the vector MK. Okay, so probably the easiest way to work out MK is to go from probably go from M to H and then H to K. So that's what we're looking for here. Before we can do any of that, it'll be useful to know what the vector HG is. To go from H to G, well, we need to go minus H and then minus G. So we're going from H to O and O to G. Notice the arrows are going the other direction. That's why we've got some negatives there. So the vector HK, that will be 3/10 of what we just said. So minus H minus G. And then the vector MH, because this is a midpoint, this vector is going to be a half H. So we just need to work out then a half H plus 3/10 of minus H minus G. Got a bit of fraction work to do here. So a half H, remember we multiply like a single bracket, so we get minus 3 over 10H minus 3 over 10G. Notice here we can simplify the h's. 1/2, of course, is equal to 5 over 10. So 5 over 10 minus 3 over 10 is 2 over 10. We're not quite finished at this point because 2/10 is the same as 1/5. And so we get our final answer for MK, which is 1/5 of H minus 3/10 of G. Okay, and on to a very typical functions question here. Okay, if you want any help with this particular kind of question, then do check out the video above where I go through all of IGCSE functions in about 40 or 50 minutes. Right, so let's go through this. So find f of 2, and we're given all these functions at the top here. So if I want to work out f of 2, wherever I see an x, I'm going to put a 2. So I'm going to copy out that function, this part on the right hand side, and wherever I see an x, I'm going to put a 2. So we get 2 times 2 here, and that gives us then 5 minus 4, which is equal to 1. So very standard 1 mark question there. And now we need to use a little bit of composite functions here. H of f of 2. So we now know what f of 2 is equal to. So we now know it's equal to 1. So if I take h of f of 2, I can replace this part here, f of 2, with just 1. So I want to work out h of 1 here. Well, if I put 1 into the x here, I'm going to get 3 over 1, and that's equal to 3. So it's a very standard question, a little bit D, E grade stuff, and then we go straight into the C and B grade. Now, find x when f of x is equal to 10. So I make this whole function equal to 10. That means 5 minus 2x is equal to 10, and then I just solve it from there. The plus 5 is kind of annoying. What's the opposite of adding 5? Well, minusing 5 on both sides. This cancels, giving us minus 2x. 10 minus 5 is 5. And now we've got a minus 2x here. So we want to do the opposite of timesing by minus 2. We want to divide by minus 2 on both sides. That gives us x is equal to 5 over minus 2, which we could write in lots of different ways. Minus 5 over 2 is my favourite, or minus 2.5. That is also fine as well. And now we need to find x when h of x, so let's take our function, so 3 over x, that's h of x, is equal to g of 2. Now if I've got g of x is equal to x squared, well g of 2, that's going to be 2 squared, and that's equal to 4. So essentially it wants me to work out here 3 over x is equal to 4. We can do a little bit of rearranging here. So I'm going to times by x on both sides. Gets rid of the fraction here. So this gives us then 3 is equal to 4x, and therefore x itself must be equal to 3 over 4. So don't be afraid in these function questions, when you get fractions, that's perfectly normal. Now the next part is this j to the power of minus 1. J inverse is the better way of saying it. So we want to find the inverse of this function j, which is 2x plus 3. So we have a three-step procedure. First of all, we make the function equal to y. Then we switch over the x's and the y's. And now we want to make y the subject. Easiest way here, we're going to minus 3 from both sides. That gives us x minus 3 is equal to, well, this cancels, so 2y. And then we want to get the y on its own. What's the opposite of timesing by 2? Dividing by 2. So we get y is equal to x minus 3 over 2. So that's going to be our inverse function. Again, that video I recommended earlier, again, I'm going through this quite quickly, but again, I'll go through this in a lot more detail in that video. Now, a little bit of algebraic fractions here. We need to write f of x plus h of x plus 2 as a single fraction in its simplest form. So f of x is equal to 5 minus 2x, h of x is 3 over x, and then we have a 2. The key strategy here is to get the denominator the same to everything. So what I'm going to do here is I'm going to multiply top and bottom here by x, kind of unsimplifying the fraction. 3 over x I'm going to leave alone. I'm going to unsimplify by put 2x over x. Notice I could simplify back to our answers, but the key point here is that we have x in the denominator of all of them, which means we can just add the tops together here. Nice and straightforwardly. Over x. Again, we just need a little bit of expansion and simplifying here. So we get 5x minus 2x squared plus 3 plus 2x all over x. If we simplify this down, we have a minus 2x squared that stays as it is. 5x plus 2x is 7x plus 3 all over x. And we have it as a single fraction, tick, in its simplest form, also tick as well. Now it gets a little bit trickier, a bit more unstandard here. So f of x all squared minus f of x is some quadratic, and we need to work out the quadratic here. Okay, so f of x first of all, let's just write down what that function is equal to. That is 5 minus 2x. Floating equal sign there. So f of x all squared, well that's just 5 minus 2x all squared. Now f of x, that's where it gets a little bit confusing. So f of x itself is 5 minus 2x. So we want to work out f of 5 minus 2x. We're a bit Inception-like here. We're inserting into this x a 5 minus 2x. So we get this. And then a little bit of expansion here. We've got 5 minus 10 plus 4x, which we can simplify to minus 5 plus 4x. So we have 5 minus 2x all squared minus 5 plus 4x. So we just need to expand this out. Remember, squaring something, you times it by itself. With this minus here, this applies to both, so we get a plus 5 and a minus 4x. Expand this out, standard procedure, we get 25 minus 20x plus 4x squared plus 5 minus 4x. This then gives us 4x squared minus 20x minus 4x is minus 24x. 25 plus 5 is 30. So we need the a, the b, and the c here. That gives us then 4 minus 24 and 30. And the last thing to do here is to find x when the inverse is equal to 10. So we go back to our h function, which is 3 over x. There's a couple of ways you can do this. Again, we could just find the inverse function like we've done before to get y equals 3 over x. We swap over the x's and y's and make y the subject. If we do this, actually we'll get exactly the same function. So it's an inverse of itself. And all we're saying here is the inverse, which is actually itself, is equal to 10. So then we just solve the equation. And a quick solving of the equation here gives us x is equal to 3 over 10. Again, there's another way of doing this as well, but again, let's stick to the standard methods that we already have. Okay, question 8 here. So a triangle, I've got a 3D kind of problem here. Diagram shows triangle ABC on horizontal ground. So ABC is the flat, so to speak, and then it's going upwards. BP and CQ are vertical poles of different heights. That's important to know. This is 4 and this is 3. And AQ and PQ are straight wires. First thing we need to do is show the angle ACB, so the angle right down here, is equal to 117.5 degrees. This is almost identical to a question we've already seen and give you lots of marks for this kind of question. That's why I'm popping it in. So this would be then 15 centimeters, 15 meters, 8 meters, and 20 meters. We're looking for this angle. Again, we've got that situation of 3 sides and looking for one particular angle here. So we need to use the cosine rule from before. Again, just a quick reminder of what it looks like here. And notice this is the angle we're looking for. So the side opposite is small c, the other two are a and b. So we can actually work this out in one calculation, do it slightly differently than what we did before. So we have 8 squared plus 15 squared minus 20 squared over 2 times 8 times 15. So this is where the, you can see me stream. This is where the calculator comes in handy here. So we go to inverse cosine, so shift and here. Then we're going to set up our fraction. So we have 8 squared plus 15 squared minus 20 squared all over 2 times 8 times 15. All we have to show is this working and you'll get all the marks. There we are, 117.54. ... And that will round to exactly what they've given us here in the show that question. Now we need to calculate the area of triangle ABC. Now we know this angle is 117.5 degrees. We can use the triangle formula. So that's a half AB sine C. Make sure the A and B are exactly the same as what we've used here. So we have a half times 8 times 15 times sine of the angle in between. Again, we just pop this into our calculator. I'll do it on this one here instead. So we have 0.5 times 8 times 15 times the sine of 117.5. That gives us then, double check, putting everything in correctly, 53.2206 ... and that gives us 53.22 square meters. Okay, and next question, calculate the length of AQ. So that's this side up here. Notice we just have a right angled triangle here. So if I draw, oh, that's a bit weird. If I just draw this in, that's also slightly weird. Let me get the rubber out. Whilst I'm fixing this, feel free to like the video. It helps to spread to more people in the YouTube universe. So here we are. This is 4 meters. This is 15 meters, and we're looking for this. So here we just got a standard Pythagoras. I encourage students just to go directly to this. So just like it is a magnitude of a vector, for example, and just type this in directly. So the square root of 4 squared plus 15 squared. Again, if we go to our calculator, we can just go shift 4 squared plus 15 squared. Again, SD button is our hero here, 15.52. So 2 decimal places, 15.52 meters. Now we need the angle of elevation of Q from P. So let's just work out exactly where that is here. So angle elevation of Q from P. So we start at P. Imagine I draw a line all the way across here. And we're looking for this angle here. So it's important to identify what angle we're looking for. This is a right angle here as well. Now if this height is 3 and that height there in total is 4, then this small height here is going to be equal to 1 meter. And we know already that this is 8 meters. It's the same length as down below. So essentially we've got a triangle, and it's always good to draw it out separately here. So if I draw it out, where our height here is 1 meter, this is 8 meters, and we're looking for this angle here. So if we want to use SOHCAHTOA, that's probably the best way here. We've got the adjacent side next to the angle, because this is what we're looking for, our question mark. This is going to be the opposite, so we're going to be using tan here. So tan of the angle, let's just call it theta, is equal to opposite over adjacent. Remember your SOHCAHTOA. So that's going to give us 1 divided by 8. And we're looking for the the theta. So what's the opposite of tanning an angle? Yep, we want to inverse tan on both sides. So theta is going to equal tan inverse of 1 over 8. So we just pop this into the calculator. Make sure you know where it is. So shift tan, and then generally put this in brackets. Again, you can do it as a fraction or a decimal, but 1 over 8, pop it in, and we get 7.125 degrees. Again, just do a double check here. I'll put this in. Does 7 degrees make sense in the context of the question? So if this is 1 and this is 8 and this is long, then that's probably going to be a small angle, so that makes some sense. Always do a common sense check here. So 7.125, so that gives us 7.13 degrees. Now another straight wire connects A to the midpoint of PQ. Okay, so let's pop that in. So PQ is here, and another line is connecting up here. Okay, and I assume we need to work out its length or something like this. Angle between this wire and the horizontal ground. Okay, so it hits here. We've got a horizontal here, so we want to create this right angled triangle here. And this is going to hit here like so. What do we know so far? So if it's halfway or the midpoint up, this length up here, it's going to be halfway of 3 and 4. So this here is going to be 3.5 meters. We just need to work out one more bit of information. The one that comes to mind here, because we're looking for this angle here in particular, so let's call that theta. Probably the easiest thing to work out would be this length down the bottom. So it's the midpoint of PQ. It's going to be the midpoint here as well. So we end up essentially with a right angle triangle. If I draw this out, well, this is half of 8, which is going to be equal to 4. This is 15 meters. So again, we're using that, exploiting this idea of the midpoint here, and it's going to be the midpoint down here as well. So this is 4, this is 15. Once we've worked out that side, we can use this side as well to then work out the angle. So first thing I want to do is work out here. So this is going to be this length. It's going to equal the square root of 4 squared plus 15 squared. Again, this can just go into the calculator. We'll get something in terms of a third. So yeah, the square root of 241. Now we look at the triangle we're actually considering here, where this bottom length is what we worked out. This here needs to be 3.5 meters, and we want to work out the angle between it. So again, we're going to be using tan because this is the adjacent, this is the opposite, and this is our theta. So tan of theta The opposite, 3.5 over the root of 241. So theta is going to equal tan inverse of 3.5 over root 241. And we pop this into the calculator. If there are any errors that you spot in this video, please let me know. I can do an update. And that .5. Okay. And that gives us, an angle of 12.705, and that simplifies to 12.71 degrees to 2 decimal places. Okay, on to question 9 here. So we can sketch the following graphs. Each sketch indicates any intercepts with the axes. Okay, so the kind of cheap way of doing it here, of course, we could put it into y equals mx plus c form, but we can also use this idea. So when x is 0, so when we put x is 0 in here, then we're left with minus 2y is equal to 10. Therefore, y is equal to minus 5. So we know the point 0, minus 5 is on here, and we can do it the other way around. So when y is 0, 5x is equal to 10. Therefore, x is equal to 2. So we know the coordinate 0, 2 also exists. So we go 0, minus 5. That's going to be down here somewhere. We know 0, 2. So it's going to be a fairly steep line, like so. And we can then just join them up. Again, we put in the intercepts, which is the most important part here. We don't actually have to write on, strictly speaking, what the gradient is here to get the 2 marks. This one here, again, we want to sketch our quadratic. Again, first of all, we know that the y-intercept is minus 6, so we can pop that down here. To get the x-intercepts, we just solve our quadratic, so we make it equal to 0. This is one that factorizes. So what two things multiply to give you minus 6, add to give you minus 1. That's going to be minus 3 and plus 2. Therefore, x is 3 and minus 2 is our solution. So we've got 3 here and then minus 2 here. We know it's a positive quadratic, so it's going to be an N shape, or U shape, sorry. And then we can just connect everything up here. So we get a graph. The minimum point, by the way, will be down here somewhere. And then we come upwards like so. Strictly speaking, we don't need to work out the minimum point, but we could do that through differentiation as well, or the axis of symmetry. For this question here, so again, very useful tip here is when x is 0 to see what happens. So y is equal to 2 to the power of 0. That's equal to 1. So it's going to go through at 1. And because this is a positive and also greater than 1, we're going to get a graph that looks like this, where we have an asymptotic behavior. So it never actually goes below the x-axis. Okay, from here they want us to do some differentiation, which is an important topic, particularly towards the end of the paper. So find the derivative of this particular function. So to work out a derivative, any numbers, they will just disappear. You can ignore those. Then we look at the 8x. So if it's just an 8x to the power of 1, we just read off the constant in front, so that's just 8. And then to differentiate this, again, remember your differentiation rules. Take the 3, bring it to the front. So we get minus 3 times 4/3, and then reduce the index by 1. So we're going to change that to x squared. We get a nice cancellation here. So that's going to leave us with just 8 minus 4x for our derivative. And now it wants us to work out this derivative. So it's the same function at x equals 1. So we want to work out the derivative and x is equal to 1. So we just substitute 1 in, just being careful of negative numbers. Minus 4 times minus 1 is plus 4. And that's going to give us the answer of 12. With a weird moving 12. There we are. Okay, next part of the question. The tangent is drawn to the graph, so it's the same function, always double check. The gradient of the tangent is minus 28. Find the coordinates of the two possible points where this tangent meets the graph. Okay. First of all, we need to be careful. I just realized in the previous part, I'm getting tired at this point, this should be a squared, of course. So when we actually put this in, let me notice the reason I checked this and found this out is because two possible points. We need a quadratic at some point. Notice when I substitute this in, I didn't get a quadratic, so I had to be very careful with this. So let's go back. This is a good show of double checking and making sure you go through your work carefully. So 4x squared, so 4 times minus 1 squared, so that gives us 8. Minus 1 squared is 1. 1 times minus 4 is minus 4. So yeah, it does give us 4 here. And now it wants us to work out the two possible points where the tangent meets the graph. So we take our derivative, and we want to find out when this gradient is equal to minus 28. So essentially we need to solve this equation here. So if we minus 8 from both sides, we get minus 36. Again, we can divide through by minus 4. It gives us x squared is equal to 9. And therefore x is equal, and this is where to be very careful, plus or minus 3. So our x coordinates will either be minus 3 or they will be plus 3. Okay, now we've worked out the x coordinates, we need to work out the y. So we take our original function, so y equals 5 plus 8x minus 4 over 3x cubed, and work out the y coordinates for both. So when x is positive 3, y is equal to 5 plus 24 minus 4 thirds, 3 cubed. This simplifies to 29, and 3 cubed is going to be positive 27. Get a cancellation. It gives us 29 minus 36, which is minus 5. So our first coordinate will be 3 minus 5. And we do exactly the same process for minus 3. So when x is minus 3, y is equal to 5 minus 24 minus 4 thirds minus 3 cubed. So that gives us minus 19. This is going to give us minus 4 thirds times minus 27. You can still get the same cancellation. Minus 4 times minus 9 is positive 36. And that's going to give us positive 17. So we get minus 3 and 17. And just being careful as you go through the algebra, go through your substitution, making sure you get to the right answers. Okay, and the last question here. So another differentiation question. So for the function, we need to work out the stationary point or points and whether they are maximum or minimum. Again, a much more advanced skill on the IGCSE course. So as soon as I see the word stationary points, we need to differentiate. So I'm going to work out f dash of x here. So 3 comes to the front, reduce the index by 1. 2 comes to the front, minus 5 times 2 is 10, reduced by 1. Differentiate here, and we get a plus 3. Now we need to set that to 0, so stationary points. We want to let the derivative f dash of x equals 0 here. So we get 3x squared minus 10x plus 3 is equal to 0. And we hope it factorizes, that's always the hope here, and we get a minus 3 and a minus 1, so that works very nicely. So therefore x is equal to 1 over 3 or 3. So those are the x coordinates of our stationary points. However, we do need to know what the y coordinate is. So when x is a third, y is equal to 1/3 cubed minus 5 lots of 1/3 squared plus 3 lots of a third. So that's going to give us 1 over 27. 1 over 9 minus 5 over 9 plus 1. Again, I just used a calculator at this point to simplify here. Again, no reason to do anything else. So we've got 1 over 27. Your fractions are very good at simplifying these things for you. So 5 over 9 plus 1. That's going to give us then 13 over 27. And when x is equal to 3, 3 cubed minus 5 lots of 3 squared plus 3 lots of 3 gives us 27 minus 45 plus 9. Okay, I think that's 9. You have to be careful of tiredness in this exam. It's 2.5 hours, so you do have to be very careful. So that's minus 9. So we have the two coordinates. We have 1/3 13 over 27 and 3 and minus 9. Now it's kind of a lazy way you can actually do this. If you take a general cubic, so a general positive cubic, it always has this particular shape. So the maximum comes first, and then the minimum comes second. So if we take our coordinates, the third needs to be the maximum, and 3 needs to be the minimum. And it makes sense from the y coordinates we have here as well. The official way of actually working this out is working out a double derivative. So if we differentiate this again, so this thing here, we get 6x minus 10. And then if I put in, for example, when x is 3, so this is what I said was the minimum. Okay, a little bit of lag. There we go. So when x is equal to 3, so if I put this in the double derivative, we get 18 minus 10, which is 8. And because this is greater than 0, it must be a maximum. If we put a third in, you'll get the other way round, and that will, apologies, greater than 0, therefore it's a minimum. And if you put in a third, that'll be less than 0, and therefore it will be a maximum point. Okay, hopefully that was helpful to you. I did speed through some of the last parts of this paper as well. Again, if you want to go through anything or you spotted a mistake, I'm always happy to hear about those in the comments. And if there is a mistake, I will make an update to this paper. Right, absolutely perfect. If you want to review all things paper 4, and you think you need a bit more practice paper 4, getting yourself ready for those exams, then check out the video right in front of you where I go through that over about 2 hours, those really, really important topics.